Hello, for number 15, we have a kite, and the area formula for a kite is, area equals 1/2, and then diagonal 1 times diagonal 2. So we just need to figure out what both lengths of the diagonals are. For mine, I'm going to have this highlighted yellow one be my diagonal 1. So in order to find diagonal 1, we have to figure out what this second part is that I'm going to label x. So we need to figure out what x is in order to solve for that. In this one, we would need to know two other sides of the triangle. So in this one, we only know one side of one of the right triangles that are formed. So we're not going to be able to solve for x right now. But if you remember, in a kite, that one diagonal that connects the two vertices that meet at the different side lengths, those are congruent to each other. So if one of them is labeled y, the other one would be y as well. So using that information, we can figure out what our second diagonal is, because it's going to be equal to 2y. And if we look, one of the triangles that that diagonal is a part of, we know two of the other sides. So in this purple highlighted triangle, we know the hypotenuse is 18, and then one of the legs is 16, and the other leg is going to be y. So we need to use Pythagorean theorem in order to solve for y. And Pythagorean theorem, remember, is the a squared plus b squared equals c squared. And we know c is the hypotenuse, so that's 18 squared. And then we're going to have y squared plus 16 squared. So that is how we are going to set up the equation to solve for y. So let me just pull up, my calculator really quick so we can figure out what all of these equal. So 16 squared is going to be 256, and 18 squared is 324. Oh no, I'm erasing stuff. Sorry. Okay. So we're going to have, let me just turn off my drawing mode. It's on Draw with Touch. There we go. So y squared, why is it not letting me right? So sorry. So we have y squared plus 16 squared, which we know is 256, equals 324. We want y squared by itself, so we're going to take 324 minus 256. That gives us 68. And we're going to take the square root of 68, which does not give us a whole number. So let's see, I think 4. Okay. So if we were to factor this, we would get 4 and 17, and 4 can be factored into two 2's. So our simplified answer is going to be 2 square roots of 17. And that is our y value. So knowing what our y value is, we're able to figure out what the second diagonal would be. So D2 is going to be equal to 2 times 2 square roots of 17, which would be 4 square roots of 17. So knowing that, we're able to plug that into our equation. Now we need to figure out what D1 is going to be. Looking at our picture, we now know that y is 2 square roots of 17. So in this yellow triangle in the top left, we now know two sides, which gives us enough information to solve for x. And again, we are going to be using Pythagorean theorem for that one. So y is the hypotenuse, because that is opposite of the 90-degree angle. So we would end up with x squared plus 2 square roots of 17 squared equals 11 squared. Remember, when you're squaring the 2 square roots of 17, you can just type it all into your calculator. But when you are squaring this, you are squaring both the 2 and the square root of 17. So that's going to come out to be 68. And then 11 squared is 121. So if we take 121 minus 68, gives us 53. So x squared equals the square root of 53. Oh, sorry. Just x equals the square root of 53. So we subtracted and took the square root all in one step. And we would be adding that to 16 to get our D1, or diagonal 1. And because we want our answer to be as accurate as possible, we're not going to type that into our calculator quite yet until we get to our area formula. So now we know that the area is equal to 1/2 times the 16 plus the square root of 53 times 4 square roots of 17. And we're just going to type all of this into our calculator, and we can round to 1 decimal point. 16 plus the square root of 53. And you want to type it in the same way that it looks, so with the parentheses, so that you know that your answer is going to be correct. And that gives us about 191.9727. So if we rounded it to 1 decimal point, we would get 192.0. So one of those, if you gave either of those answers, it would be correct, unless it tells you specifically where to round your coordinate point.